Assalamualaikum. My name is Muhammad Haribi Abdullah from Section 3, Group 6. My name is Muhammad Haribi Abdullah. And today I want to discuss and present about the heat convection lab. For the abstract, this experiment followed the guideline of the BMM3531 Engineering Thermodynamics Laboratory. The experiment was intended to demonstrate the working principle of heat transfer variation in free convection mode for various power, as well as the effect of the air velocity on heat transfer characteristic in forced convection mode. The goal of the laboratory is to build a heat convection experiment using our own parameter, operation rule, and variable. In this experiment, both free and forced convection are used. Forced convection will require air movement, whereas free convection will not. For the introduction, the flow of fluid that allow heat to be moved from one side to another is known as convection, while often regarded as a separate type of heat transfer. I'm typo. Convective heat transfer involves the process of conduction, heat diffusion, and advection. Convection is the most frequent route of the heat transfer in liquid and gas. Convection is a kind of heat transfer that uses fluid flow to transmit the heat. There are two types: heat convection, which is forced convection, and natural or free convection. For forced convection, is a kind of heat transfer that involves force fluid to circulate in order to increase heat transfer. That can be done with a ceiling fan, a pump, a suction device, or something else entirely. Heat rise is a phrase that many people are familiar with. Convection heat transfer from all to the surface of material as temperature surrender may be calculated by using Newton's law of cooling, where Q equal to HA multiplied by T surrounding minus T ambient. The coefficient of forced convection, the heat is derived using an empirical correlation of the form. Nu equal to CRE power of n multiplied by Prandtl number power of m. For free convection, natural convection, also known as free convection, is a mass and heat transport method in which fluid motion is caused solely by density variation in the fluid caused by temperature gradient, rather than by any external source. Natural convection occurs when a fluid near a heat source absorb heat, lose density, and rise due to the thermal expansion. Heat transfer correlation from the Nusselt number are commonly described in terms of the Rayleigh number in the case of free convection. In natural convection, simple empirical correlation for the average Nusselt number as a follow. NUX equal to C multiplied by RA X power of n. And for the Rayleigh number equal to GRL multiplied by Prandtl number equal to G beta multiplied by T wall minus T ambient multiplied by L power of 3 divided by V power of 2 and multiplied by again Prandtl number. That's all for me. Thank you.
Assalamualaikum. My name is Aziz Iman bin Muhammad Noor. My meeting ID MA19065. Today I want to talk about experimental procedure. Okay, for the experiment 1, which is free convection, the LS 17004 FFC free and forced convection apparatus was placed on the table. Adjust the adjustable leveling foot is necessary. Second one, the 3-pin plug was plugged to the 240 VAC main power supply and turn on the power supply. The third one is the power supply unit K in front of the control panel was switched on. Fourth, the desired test specimen was selected and the shape of selected test specimen was recorded. And then the test specimen was placed to the plate heater placement. Lock it with the wing nuts provided. And then the test specimen heater cable was connected to the heater work socket, which is located at the back of the control panel. And then took the digital handheld temperature probe and meter, measured the initial temperature in the air duct by putting the temperature probe into temperature point E. And then the temperature probe was placed to point D after reading the temperature at point E. And then the power supply was regulated to 50 watt by turning the power regulator. And number 10, the temperature was measured at point D for every 5 minutes. Continue the experiment until steady state was achieved, where the temperature reading at point D became constant. And then the experiment was repeated with other powers. And then the experiment was repeated with different types of test specimen, ensure the previous heat plate is properly cooled before removing it. And then the film temperature was calculated from the temperature result obtained. Then the thermophysical properties of gases at atmospheric pressure table provided extract out all the relevant information. And then the volumetric thermal expansion coefficient, Rayleigh number, Nusselt number were calculated using the correct equation. And the last one is, finally, the coefficient of convection heat transfer was calculated, and hence the heat loss by convection using the correct equation. That's all for me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Irfan bin Abdul Jalal, Matric ID MA19315. Now I will continue to present about the results and calculation. Okay, this is the data and graph for free convection. We have to collect data for power 25 watt, 50 watt, 75 watt, and 100 watt. So these are the data that we have obtained from the experiment for each power. After all the data are gathered, we create a graph of free convection for temperature against time. Next, this is the sample calculation of free convection for power of 25 watt. So, first thing is we need to get the properties value of the temperature at 40.6 Celsius from table A15. Then, there are 4 different formulas that we needed to use in order to find the value of heat loss by convection. So, we substitute all the properties values and recorded the results in this table. So these are the calculation results for power of 25 watt. Now this is the data and graph for forced convection. In forced convection, we needed to collect data of velocity 0.2, 0.6, 0.9 and 1.1 meter per second for power of 100 watt. So these are the data that we have obtained for each velocity. This is the graph of forced convection for temperature against time. Next, this is the sample calculation of forced convection for velocity of 0.2 meter per second. Firstly, we listed all the properties values of the temperature at 50.3 Celsius from table A15. And then we needed to use the formula of Reynolds number, Nusselt number, and coefficient of convection heat transfer in order to find the value of heat loss by convection. We substitute all the properties values in this formula and recorded the results in this table. So these are the calculation results for velocity of 0.2 meter per second. I think that's all from me. My team member will continue this presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqmal bin Janudi. My ID matrix is MA19304. Okay, today I would like to explain about our discussion for the lab 2, which is convection. So the first question is discuss the variation of heat transfer in free convection mode for different power. So as we all know, the convection is the process of transferring heat by largest movement of water droplets such as gas and liquid. So there are 2 types of convection, which are natural convection and forced convection. So natural convection is produced by different density in liquid due to the temperature difference such as a rising air temperature, while the forced convection is occurring in this mode of heat transfer with some external sources like blower is used to cause the motion of the air. Okay, for the second question, discuss the effect of air velocity to the heat transfer characteristic for the forced convection mode. So, as we all know, the forced fluid movement, or we call as forced convection, occur under the influence of some external agent such as wind, pump, and steering pan. So, forced convection depends on the type and physically property of the fluid in terms of temperature, flow speed, shape, and size of the passage where the forced flow of the liquid or gas occur. Okay, next, for the third question is indicate the difference between laminar and turbulent flow. So, as we all know, laminar flow is smooth and streamlined, while turbulent flow is irregular and chaotic. So, in turbulent flow situation, the increase in the rate of heat transfer is greater than in a laminar flow situation. So, this is because the number of Reynolds increase further during decreasing due to the turbulent effect, because this is the most important as the second stream of higher Reynolds number compared to the laminar flow, which is lower of Reynolds numbers. Alright, for the question 4, discuss the effect of the convection mode on the efficiency. So, in convection, there is actual movement for the free particle heat transfer, where in conduction, the particle only vibrate at their position and transfer heat. Due to this, kinetic energy transfer in convection is faster than conduction, and hence, convection is the more efficiency way of the heat transfer compared to the conduction. For the question 5, discuss the effect of extended surfaces on the heat convection. So, as we all know, extended surface, also called as fin, are generally used to improve the rate of convective heat transfer between the object and the surrounding. So, this extended surface of fin are used to facilitate heat transfer due to the increased cross-sectional area where the convection process takes place. For our experiment in first, we achieved a convection heat transfer coefficient of H equal to 98.75 watt meter square per K, and the heat loss of Q equal to 6.18 watt per meter square for 25 work at time equal to 95 minutes. So we found that H equal to 109 and Q equal to 10.66 for the 50 watt power supply at T equal to 80 minutes, and we calculate the H equal to 111 watt meter cube per K and Q equal to 12.99 for the 75 watt power supply at T equal to 75 minutes. So lastly, we got H equal to 115 and Q equal to 70 for the 100 watt power supply at T equal to 70 minutes. So next, for experiment 2, for the velocity of 0.2 meter per second, we achieved a convection heat transfer coefficient of H equal to 24 and the heat loss of Q equal to 0.1 at T equal to 870 seconds. For 0.6 meter per second, the result where we got is H equal to 41 and the Q equal to 0.19 at T equal to 870 seconds. For 0.9 second, we determine H equal to 51 and Q equal to 0.1683 at the T equal to 900 seconds. And finally, for 1.1 meter per second, we got the H equal to 56.76 and Q equal to 0.147 at T equal to 900 seconds. Pursue to the next chapter, which is conclusion. So we can conclude that the convection heat transfer coefficient and the heat loss due to convection increase with the power supply. So convection behave as the heating force when the wind speed increase. The convection heat transfer coefficient and the temperature drop due to the convection both increase. So from our graph and our experiment, the temperature at point D increase with the time as the power supply increase. The thermal convection graph shown in result and discussion section that the wind speed rise at 0.6 meter per second when the temperature reach the point D. However, after 0.6 meter per second of wind speed, is shown slightly decrease with time. So that's all from our group. Thank you.